Hello, welcome to Math with Mr. Dobrescu to the rescue. In this lesson, we are going to focus on solving inequalities, solving and graphing inequalities on the number line. Let's take a look at some of the symbols we have with inequalities. We have this sign, this is less than, and it's going to have an open dot. This sign is called greater than, and all is going to have an open dot. Less than or equal to, close dot, and greater than or equal to, and also a closed dot. I'm going to explain what those open dots and closed dots are going to mean in the following examples. Let's take a look at the first example here. We have 3x plus 3 greater than 6. You know, I told my students in the past that inequalities and equations are like brothers and sisters because they are very, very similar. When we are solving inequalities, we are following the same steps as when we solve equations until the end. Okay? So if this would have been an equation, we would have subtracted 3 on both sides. So let's do the same thing. Let's use the subtraction property of addition, of equality, and let's subtract 3 on both sides. Whatever we do to one side, we do to the other side. And let's see what's going to happen. 3 minus 3 cancel out. So we are left over with 3x greater than 6 minus 3 is 3. And finally, we would have to divide both sides by 3 in order to get the x by itself. 3 divided by 3 simplifies to 1x, or just x, greater than 3 divided by 3 is 1. This is our final answer. But since this is an inequality, we have to grab this inequality on the number line. So if this is 0 and this is 1, we go to 1, and at 1, since this is greater than, we are going to have an open dot. And then we are going to follow the arrow. The arrow points to the right, so let's go to the right, and that's going to be our answer. And let's in the interval notation, this would be an open at 1, and then we go to positive infinity. To positive infinity, and that's how we, this is called the interval notation. 1, positive infinity, and since this is an open dot, we have this bracket. Actually, we have this little parenthesis. Okay? Not very challenging. Let's look at another example here. This example, we have 1 over 5x plus 3 less than or equal to 4. Again, our first step would be to subtract 3 on both sides, just like solving equations. Whatever we do to one side, we do to the other side, again by the subtraction property of equality. 3 minus 3 cancel out. So now we have 1 over 5x less than or equal to 4 minus 3 is 1. And now we have an option here. Since we have a fraction here, every time we have a fraction, I told my students to use the opposite reciprocal method when we use this type of inequalities. Similarly to solving equations, right? If we multiply by the reciprocal of 1 over 5 is 5 over 1. So let's multiply both sides by 5 over 1. Whatever we do to one side, we do to the other side. 5 over 1. And because we multiplied by the reciprocal, you see now we can cross cancel the 1 and the 5. So now we have the x by itself. X less than or equal to 1 times 5 over 1 is just 5. Final answer. X less than or equal to 5. Because this is an inequality on the number line, we go to positive 5. So let's say positive 5 is here. And in this case, we have less than or equal to. Remember, we are going to have a closed dot. So at 5, we are having a closed dot. And now following the arrow, we go into the left. A closed dot means that 5 is going to be included in the answer. And the open dot was, if that would have been an open dot, 5 would have not been included in the answer. With the closed dot means 5 can be included in the answer, right? And using interval notation, at 5, since this is a closed dot, we are going to use brackets. Brackets, so at 5, we are going to have a bracket, and then we go all the way to negative infinity. Negative infinity. Okay? Let's take a look at another example here. In this example, we have 6 minus 3x greater than or equal to negative 3. Okay? And I'm going to ask you the question here. What should we do? What should be our first step? Should we subtract 3x or subtract 6x or divide by negative 3 first? What should we do here? Okay? So be very, very careful here because we have negative 3 times x, remember? And then we would have to use the reverse order of operations by subtracting negative 6 first on both sides. Whatever we do to this side, we are going to do to the other side. Right? 6 minus 6 canceled out. Now we are left over with negative 3x greater than or equal to negative 3 combined with negative 6 becomes negative 9. Negative 9. And finally, now we are going to divide both sides by, of course, negative 3. And I want you to remember something that is very, very important, and we gotta always use it anytime we divide or multiply a negative number. When we have an inequality, the inequality sign is going to change. Okay, so from greater than or equal to, we are going to change it to less than or equal to. Pay attention here. Be very careful. I'm going to put the star by this problem. I want you guys to take a pause and kind of really, really understand that every time we divide by a negative number or multiply by a negative number, the signs are going to change. From greater than or equal to now becomes less than or equal to. I'm going to teach you a lesson specifically on why the sign changes when we divide and multiply by a negative number. So we have here negative 3 divided by negative 3 becomes a positive 1x. And now it's going to be less than or equal to negative 9 divided by negative 3 becomes positive 3. Final answer. But again, please remember, every time we divide by a negative number, or if we multiply both sides by a negative number, when we solve inequalities, the inequality sign changes. It flips around, right? So now we have x less than or equal to 3, final answer. So on the number line, we go to positive 3. And then because we have less than or equal to 3, it's going to be closed at 3, which means 3 is going to be included in the answer. And then we are following the arrows, and we go to the left of 3. And again, using the interval notation, at 3 we have a bracket. And then we go to the negative infinity. And that's going to be our answer. Okay, let's take a look at another example here now. In this example, we have a compound inequality. Remember, a compound means 2 inequalities together in one. So let's see, how can we solve this inequality, the compound inequality, when we have 2 inequalities in one, right? So for example, let's say if I cover this part of the inequality, we have 6x minus 4 less than or equal to 8. And if we would have to solve that, we would first have to add 4 on both sides, right? Plus 4 on both sides. And if we cover this part of the inequality, we have negative 10 less than 6x minus 4. And again, if we have to solve that, we'll have to add 4 also on both sides. So let's add 4 also on this side. Okay, and that works. So negative 10 plus 4 becomes negative 6 less than this cancels out, 6x, and less than or equal to 8 plus 4 is 12. And now let's see what's going to happen here, right? Now we have to divide both sides by 6 in order for us to get the x by itself. So let's divide by 6 on both sides. 6 and 6 simplifies to 1x. Greater than negative 6 divided by 6 becomes negative 1. And then less than or equal to 12 divided by 6 becomes 2. And let's see if we can graph this on the number line. So let's draw a number line here. First of all, let's go to negative 1 first. So negative 1 would be somewhere here. And at negative 1, we know that x is greater than negative 1. We can rewrite this as here. X greater than negative 1. And also we have x less than or equal to 2. X less than or equal to 2. Negative 1 right there. Okay? So we go to negative 1, and because it's only less than, we are going to have open dot and negative 1. And it's going to be greater than negative 1. So we are going to go this way. Negative 1 is not included in the answer, right? So we're going that way. And then we go to positive 2. So positive 2 probably is here somewhere. And at positive 2, we have a closed dot because x is less than or equal to positive 2. So in this case, we have a closed dot at positive 2. And we are going to go in that direction right here. So that's going to be our answer between those negative 1 and 2. So at negative 1, we have open parenthesis, negative 1, and it's going to go to 2, and that we have a bracket. Okay? That's the notation for our final answer. Let's look at our final example here. In our final example, we see that we have 3x minus 1 greater than 5 or negative 4x plus 3 greater than or equal to negative 1. Let's see how we solve these types of inequalities. And the first inequality, we have to add 1 on both sides. Again, similarly to solving equations. We follow the same steps, not that complicated. Okay, so let's add 1 on both sides. Whatever we do to one side, we do to the other side. 1 and negative 1 cancels out. We are left over with 3x greater than 6. And then we have to divide both sides by 3. 3 divided by 3 becomes a 1x, simplifies to 1x. Greater than 6 divided by 3 is 2. Okay, we have one answer. And then in the second inequality, we are going to subtract 3 on both sides first. 3 minus 3 cancels out. We are left over with negative 4x greater than or equal to negative 1 and negative 3, of course, become negative 4. And now we have to be very, very careful again because we are going to divide by negative 4 in order for us to solve for x. And remember again, every time we divide or multiply by a negative number, in this case, we are dividing by a negative number, and we have an inequality. Again, I'm going to put a star by this because you have to remember that the signs is going to change. It flips around from greater than or equal to, now becomes less than or equal to. Okay? Negative divided by negative becomes a positive. 4 divided by 4 becomes a 1x. So we have x less than or equal to. Negative 4 divided by negative 4 becomes a positive 1. Now let's graph both of these on the number line. So on the number line, first of all, we are going to go to 2, right? So if 2 is here, and at 2 we have open dot. So open dot at 2, and follow the arrow that way. Okay? And the second one we have, we go to positive 1 right here. And then we have x is less than or equal to 1. So at 1 we have a closed dot. And going this way. Okay? And the final answer, using the interval notation, let me use the interval notation somewhere where we can have some room. Let me erase that. Okay. So instead of going here, we are going to, so at 2 was closed. I'm gonna do the dots right on the number line, and then we go that way. And then at 1 is gonna be, oh, the other one was open, my bad. So open at 2. We gotta go back here, sorry. So open at 2. Okay, and then close that 1 because that's less than or equal to. So let's go to 1, and now here is closed, and now we go this way. And this is open here. So our final answer using the interval notation, so we go negative infinity, and it's gonna be all the way to 1, right? And at 1 we have a closed bracket, and then we are going to have a union, and then at 2 we have a little open parenthesis because it's open dot 2. It goes all the way to positive infinity. And that's our final answer. Negative infinity to 1, bracket, union 2 to positive infinity. Okay, not very challenging. I wish you all the best as you try to solve these inequalities. Make sure you do it step by step. And again, when you solve the inequalities, follow the same steps as you'd follow equations. And then at the end, do your very best to interpret the answer and then get to the solution on the number line. Thank you all so much for watching. I wish you all the best on your mathematical adventures. And please don't forget to like and subscribe. It will help me a lot.